Okay, so for this question, you're asked to find the Taylor series of f of x equals cosine x squared over x about x initial is pi over 4. So there's nothing complicated about this question. It's just tedious. The most arithmetic you really have to do is just taking the derivative multiple times. Unless they want you to condense it into a single series, which in this case, it's not possible. As you can see, if you plug it into Wolfram, you're just going to get an infinite mess of stuff. Sometimes you can condense it down to a single summation, but not in this case. So probably they want the first 2, 3, or 4 terms. There's calculators out here, so I'm not going to do this by hand. This is why nobody answered this question, because it would take an hour. But it's real simple. First, what's the difference between Taylor and Maclaurin? Maclaurin is just when the point is 0. It's the same thing. It's just when the point is 0. If the point's not 0, then it's Taylor. So all you do is you take the derivative, and you're going to plug it into the summation formula, expand it out. Now, don't be scared of this formula. All you do is you plug in 0, 1, 2, 3, and 4 to expand it out. Then you're going to have the 0th derivative, which is the original function, then the first, second, third, fourth, x amount of derivatives. You put k as 1 factorial, 2 factorial, 3 factorial. K goes here. You'll see as we go through. So the first thing you do is you put 0 in there. Obviously, 0 factorial is 1. This raised to 0 is 1, so you end up with the original function. You evaluate the function at pi over 4. That was supposed to be pi over 4, but whatever, it's the same process. Then you take the second derivative, the third derivative, the fourth derivative. You might have to take up to 8 derivatives or 10 derivatives. If you plug the number in and the term turns out to be 0, you'll have to take like 8 derivatives to get the first 4 terms. So keep that in mind. But for the most part, you just take the derivatives. That's all you do. You take the derivatives, then you plug them into the expansion. You see how they got the 0 factorial. They got 1 factorial, 2 factorial, second derivative, third derivative, based on the n here, where the n goes into the series here, or the k in this case. K goes here, here, and here. So if you're going out to like the first 4 terms, then this is what the answer is going to look like for the first 4 terms. Each plus sign denotes a term. So first term plus second term plus third term plus fourth term, third term plus fourth term, da-da-da-da-da. As you can see, it's very long, very tedious, and that's why no one answered this question, because no one's going to want to solve this by hand, and you only got 5 minutes to talk in these videos. So, but if you're doing Taylor series versus Maclaurin series, Maclaurin is when x equals 0. Taylor is when x does not equal 0. All you're doing is taking derivatives and plugging it into the formula. It's as easy as that. There's nothing complicated about it. So when you're doing these questions, it's really wise to plug them in and get the answer before you even attempt the solution, because no one cares if you can get the answer. Look, I plugged it into a calculator. I got the answer. Whoop-de-doo. When you take an exam, the teacher wants to see the step-by-step solution, the neat see how this is neat, clear, step-by-step solution. That's what the teacher cares about. That's worth 99% of the credit on the test. The answer is worth 1%. When your homework ultimately at the end of the semester is not worth anything, because they do a grade curve at 10% of that is worth nothing. So people train themselves doing their homework to get answers and set themselves up for failure when they take the exam. Who cares about your grade on your homework? It's not worth anything. When you're doing your homework, you should be practicing writing solutions, not focusing on getting 100% on your homework. Getting 100% on your homework is going to not help you do good at an exam at all, and it's not ultimately worth anything. So just keep that in mind if you're watching this video, and have a great semester. Thanks.